Click record. Okay, all right. Um, so happy, I guess, 10th week of the semester. We are over halfway done at this point. Good job. Um, I'm feeling incredibly tired today, so I apologize if I'm a little bit on the laggier side. I know that the wind has been an issue with a lot of people. I've received a lot of emails about the windstorm taking down internet. And I know it's really windy right here right now, and probably wherever you are, as long as you're in Vegas, it's probably windy because that's just how Vegas works. So if my internet goes down during this um, stream, I don't know what we'll do, but just keep in mind, like my internet hasn't gone down yet today, but because it is windy, that could happen at any time. Um, if I can't get it back online right away, I will send an email out saying that I don't know, we'll figure things out. All right, so I just wanted to put that out there just because I'm not sure how this wind is going to hold up today. All right, so we were almost done with 3.3. There was just one problem left on 3.3 I wanted to do. There's like 2 pages left, but really just one that I wanted to do. I wanted to talk about this graph here. So one of the interesting things we now have is the relationship between f prime, f, and f double prime. And oftentimes we're given the graph of f. Just a second, let me pair this pencil up. Okay, there we go. We have the asymptotes all done. Right, asymptotes. The x-intercept and the y-intercept is plotted. The horizontal asymptote is plotted. The 0, 0 max is plotted. So now it's just looking at these breaking up points. So -1 and 1 we already took care of. 0 is the only other place that things break up. So I'm just going to kind of draw a line there just to remind myself that something happens. Oops. All right, so we are increasing from -∞ to -1, and from -1 to 0. We are decreasing from 0 to 1, and from 1 to infinity. We are concave up from -∞ to -1, and from 1 to infinity. We are concave down from -1 to 1. So increasing concave up will be this shape. Increasing concave down will be this shape. Decreasing concave down is this shape. Decreasing concave up is this shape. So we know that we have to follow these asymptotes. So it makes sense that in this interval right here, it makes this shape. So making this shape here, this is a max. We know it's a max because it said it was a max. And then down to here. And then this shape in here. So I want to go over, I know we only have 3 minutes left. I want to go over one more of these. So I'm not going to do the actual derivatives of it. I'm just going to give you the information. And if you want to, you can do the finding of the maxes and mins later, but I'm just going to give it to you and tell you what it is for this next one. So try doing the work for this one on your own. But the big thing is we have this function x minus 2 sine x, and it's only on the interval 0 to 2 pi. So that was given to us. So I'm going to tell you, where's my graph at? Oh, I have to make my own graph here. Oh man, I don't know if I have. Oh, this won't work actually. It has to be a blank graph. Okay, that's fine. Here's the information that you end up getting. There's an x-intercept at 0, 0. There's also an x-intercept at 2 pi, comma 0. There's a y-intercept at 0, 0. For these endpoints, because you have to take care of these endpoints, and if you need to get going in a minute, that's fine, but I'm going to finish this problem up. For the endpoints, you have 0, 0, and 2 pi, comma 0. No, 2 pi, comma. This isn't 1.9. This is, hold on. So I'm trying to read this off of my own notes here. Okay, whatever. This is 1.9, comma 0, not 2 pi. This is 2 pi, comma, looking at my own notes, 2 pi, comma 6.3. It's actually 2 pi, comma 2 pi, I think. Yeah. It's increasing from pi over 3 to 5 pi over 3. It's decreasing from 0 to pi over 3 and 5 pi over 3 to 2 pi. It is concave up from 0 to pi, and it is concave down from pi to 2 pi. Like I said, you would find this information out manually. I'm just giving it to you so we can draw a graph. I just really wanted to draw one more graph. There's a min at pi over 3, comma, negative 0.7. Well, I'll give you the exact number here. Pi over 3 minus root 3. There's a max at 5 pi over 3, comma, I guess I say 7-ish. And an inflection point at pi, comma, 3.1-ish. I think it's at pi, comma, pi. I don't know what this 7 one was. Pi over 3 plugged into that. 5 pi over 3 plugged into that. Why don't I just have exact numbers here? This bothers me. Why are my notes not neat and tidy? Sorry, apparently my notes got messy here, so let me just give you the exact what those would be because I want to talk about it and I know it's taking time. Sorry, give me 1 second. So this one would be 5 pi over 3 plus root 3. And this is pi, comma, pi. So here's the thing. When you do this problem, you're going to end up getting, what I'm trying to say here is you're going to end up getting like some interesting numbers over here. For the x values, we were able to make a graph that has those x values because they're just pi's. But because you have these weird values here, you end up having to do some approximating. So you approximate this guy, this minimum, to negative 0.7. This is an approximation. This is 5 pi over 3, comma, this is approximately 7-ish. I all of a sudden don't like this problem. I wanted to do one more to make sure this was so we could do practice on this, but now I don't like this problem at all. All right, that's fine. And 2 pi is approximately 6.2, 6.3, 6.3-ish. I just wanted to draw a graph. I didn't want this to go all weird. 1, 2, 3, 4, 5, 6, 7. So it goes up to 7. And then our x values that we need to draw this scale here. We have 2 pi, we have pi over 3, 0, 5 pi over 3, 0, pi, pi over 3, 5 pi over 3. So we can count by pi over 3s here. Pi over 3, 2 pi over 3, pi, 4 pi over 3, 5 pi over 3, 2 pi. For this 1.9, this turned out awful. I'm sorry I've done this to you guys. I nearly want to just say, screw this problem. For this 1.9, I'm just going to tell you that this x-intercept belongs like right around here-ish. All right, so this guy here is like right around here. Plotting 0, 0, so I'm plotting these points. Plotted that point, plotted that point. For the endpoints, we have 0, 0, and 2 pi, comma 2 pi. So we have 2 pi, comma 6.3. So 2 pi, 6.3 is ish up here. Plotted that point. These are the other points down here, the mins and the maxes that I'm going to plot. So we have pi over 3, negative 0.7, pi over 3, pi over 3, negative 0.7, somewhere in here. 5 pi over 3, 7. And pi, comma 3.1. Plotting those points. What I really wanted to do was this part down here where we do the increasing, decreasing stuff. So the places where it parts ways are at pi over 3. So pi over 3, I'll make a line. At 5 pi over 3, make a line. At 0, which is where it starts, pi over 3 we got, 5 pi over 3, 2 pi. Pi, stuff changes. At pi, 2 pi, we got pi over 3 already. We got 5 pi over 3 already. Oops. Those ones don't count. You're only looking at these guys for the breaking points. So we have those breaking points. So we have pi over 3, pi, 5 pi over 3, and 0. We are increasing from pi over 3 to 5 pi over 3. So pi over 3 to 5 pi over 3. We are decreasing from 0 to pi over 3. And then from 5 pi over 3 to 2 pi, because this all ends at 2 pi. For concave up, we are concave up from 0 to pi. We are concave down from pi to 2 pi. Now we can draw this picture. So we have this shape here, so decreasing concave up, increasing concave up, increasing concave down, decreasing concave down. So now we have the picture. We can draw the picture, and you can kind of see what the picture is going to look like just from these points. But filling in the blanks here, oops, I got that shape wrong. So it is concave up this entire way. Then it changes to concave down. And then it's concave down this shape. So I'm sorry this one was awful, but there's the shape of this graph. I really wanted that one to be better than it was. I thought I could just write the information down, but it turns out that didn't work so well. I'm going to find some other examples to do on Wednesday so we can do a few more, because the fun part of this is the curve sketching. This is the fun part over here. The annoying part is all of this in-between stuff. So I'm going to try to find some ones where we can just practice this curve sketching stuff and find a little less of finding this stuff here. So we can practice this. So we'll do that on Wednesday. I'm going to be posting some homework a little later today that'll be due on Monday of next week. Other than that, thanks for sticking around for so long. I appreciate your patience, and have a fantastic Monday. I apologize about that last problem. I didn't anticipate it to not be as great as it was. All right, everybody, have a fantastic day. Bye. Thank you. See you on Wednesday.